for what we are finding out, y equal to x square, the area under the curve from x equal to 4 to x equal to 6. The earlier the same x equal to 4, the same set of example will take it. Corresponding to that, we'll calculate the value of y. We will cross-check ourselves whether we are right or wrong. I think it should appear like a curve. Huh? Again, many will think it's a trapezium. That's the biggest problem. Yeah. Oh. It's very difficult graphically to handle things because we are not used to it. No, corresponding to this, y and x, we will just, it's a rough diagram I have put it. X equal to 4, x equal to 6, corresponding to x equal to 4, 16. This will be 36. The equation is what you have. And what was our method? We have to find out the area under the strip. So how to calculate the area under the strip? It's not a trapezium, first of all. Then I'll do integration method. So for that, first what we should do, we should assume an elemental strip or a strip of infinitesimal width. I'll bring a strip of infinitesimal width. Here is what I brought it. Now this will become dx. Let this be y. Adding like a rectangular strips of infinitesimal width of increasing height. The sum of all that from where the y varies from 16 to 36 will get the required answer. So area under the curve y equal to x square from x equal to 6, x equal to 4 centimeter to x equal to 6 centimeter. This is what I'll call area. This will call I. This we are going to integrate in this way, y dx. What is the area of the strip? Y into dx, from where x is, lower limit is 4, upper limit is 6. Now we'll substitute the value. I is equal to, what is the value of y? X square dx, 4 to 6. Solving this one from the power rule, x to the power of 2 plus 1 by 2 plus 1. 4 to 6 dx. So then this will become the value I is equal to, here only 1 by 3, x cube 4 and 6. Lower limit is 4, upper limit is 6. Then this value will be 1 by 3, 6 cube minus 4 cube. What is the value of 6 cube? 216. 4 cube, 64. Solving this will get 152 by 3, which is nothing but 50.67 centimeters square. So what I should call this one? Area under the, or simple area of yellow color region. I don't want to dump mathematical things here. Yellow color. Sir, is it not area of trapezium? You do one thing, just verify, nothing wrong. Okay, we will, nothing wrong. Okay, we'll bring the trapezium idea now. So trapezium will be like this. A straight line will be there. And how is the curve? The curve is like this, no, here. See, this is what the student has to ask a question. This is what the student has to ask a question. Now, what is that yellow color region? Yellow color region is this one. This area is what we have found out. Area of trapezium, very easy. area of trapezium is very, you can find out that. There's no issue with that area of trapezium, but ours is what? We have to find out the area of this yellow color strip, not the area of trapezium. Definitely, these two will make a difference. These two will make a difference. Suppose if I bring the same thing, the trapezium, I'm trying to stress again and again the same aspect so that you have to, is there any difference between them? Is there any difference between them? Definitely. So if you calculate area under the strip, it will be 16, this will be 36, this length will be 2. Area of trapezium will calculate. Area of trapezium is equal to half into height, 2 by 2, 16 plus 36, 52. But what should be the area under the curve is 50.67 centimeters square. So definitely this is the error, no? Area of trapezium will not be equal to area under the curve. Area of the trapezium will not become equal to area under the curve. I will choose some. So therefore, what is the only alternative available to find out the area under the curve? Just use integration. There's no other way. This is what we have found out. Able to make it out? So there's no other way. Area under the curve has to be, we have to use integration. I'll take it out this red color. This will be more meaningful. Okay, fine. So what is the primary thing? Just you have to find out the area under the curve. So this integration is what very widely useful. How to put limits? First upper limit, you can see in place of x upper limit 6 cube. In place of x lower limit 4. Then solving. Okay, we'll take the, almost I think we are in better position now compared to in the beginning. This will be the, I'll bring a curve. This particular area is needed. So therefore I'll assume a small strip. So the value of this, let it be 5. Y equal to, and let this be equal to x. I'll assume a small strip of infinitesimal width dx, and this is y. So then the area under the curve I is equal to y into dx. What is the limit? Let it be 2 to 4. So 2 to 4. What is value of y? Here y is equal to 5, no? Is a straight line, is a horizontal line. So here integral of 5 dx 2 to 4. No, this 5 has been, I'll send outside. So 2 to power 4. Here 1 into dx will come. 5 into 1, 5 we can write 5 into 1. That 5 I'll bring outside. Then in place of 1, we can write x to power of 0. Then 2 to 4. Then this will be x to power of 0 plus 1. After integration, 0 plus 1. 2 to 4. Okay, this will be 5 equal to x by 1, 2 to 4. This is 10. So I think it's quite good, no? So what is this I know? Area under area of rectangle. Area of rectangle or yellow color strip. We can find out of anything. We can find out. So this will be 10 centimeters square, we'll write it. let x be in centimeter. Or if you don't want to put units, so just end up with the square units. So therefore, what we can write, integral of some constant, what it can be written as kx plus c. What is c? C is called as integral constant. If there are no limits are there, then you have to use this one. If there are no limits are there, this one. So what is k? K is a constant. So when to bring the c, integral constant c? Whenever there's no limit. So usually this will become indefinite integral. I'll put it in a simplified way. If this is the integral of f of x dx, when you integrate this, the function will become gx plus c. After integrating, it has become some other function. What is c? C will become integral constant. No, this will become indefinite integral. When indefinite integral is basically used for like to derive an expressions, there what happen will be taking help of the indefinite integral. So indefinite integral basically used in the derivation of or indefinite integral basically used in the derivation of expressions. It will lead to expression, that's all. If we don't get any value. No other side I will write in this way, f of x dx a to b. This will become definite integral. So what is here now? Now after integration, it will become g of x plus g of x. The lower limit is a, upper limit is b. Further, when you solve, will end up in this way. So what is this? This particular thing you can call its value, no? So definite integral leads to a value. And what about the indefinite integral? Leads to an expression. We don't get any value. You can see that. But here, if I substitute like previous problem, I got the value, no, because there were limits were there. So this is only, so whenever we are going for some derivation part, we stick on to this one. What is C? How to calculate the integral constant? By initial values. The value of C is determined by initial condition. So what is integral of a constant? So already have seen integral of k dx should be equal to kx plus c, where c is an integral constant. Okay, we will put all the one by one, the different types of this one. So first, if I go for integral of a f of x, this should become a f of x dx. A is some constant. Then it will become a integral of f of x dx. This will become a into g of x plus c. Means if some certain value multiplied by a function, you have to use this particular. Similarly, integral of f of x g of x into dx. Separately, you integrate this, so we can break it up. F of x dx integral of g of x dx. I think this will really going to help us a lot. Then we will take the various some equations, what we know. Okay, let's start with this one. So I have equation y is equal to 3 x square 4x plus 5. There's a one equation. Find the area under the curve from x equal to 1 to x equal to 2. Y equal to 3x square plus 4x plus 5. See, I think there's a definitely no doubt it's a equation of parabola only. No doubt it's an equation of parabola. And how the curve put x equal to 0, it will be 5. So it will start from here. Then corresponding to x equal to 1, I'll pick up here. X equal to 2, I'll pick up here. This particular area under this curve is has to be determined. It's not a trapezium once again. It's not a trapezium. So what we do is, again, we'll assume a strip. This is Y. Small elemental area, I'll assume it. Then first what we do, area of that small elemental strip is Y dx. Such elemental strips of infinitesimal width and increasing height, if the sum of all that will give total area, I'm going to take sum, will give total area. But where I want want area from x equal to 1 to x equal to. So the limit x equal to 1 to, oh everyone is able to understand. I'll put everything once again. Everything once again. What is the area of this strip? Y dx. Right, Y dx. Now, if you add up areas of infinitesimal width and increasing height from x equal to 1 to x equal to 2, if you add up, means if you sum up from x equal to 1 to 2, then you get the total area under the curve from x equal to 1 to 2. Got it? The definition is what I'm just expressing mathematically. What is value of y? We'll substitute here. This should become equal to integral 1 to 2, 3x square 4x plus 5 into dx. So this will become 3 x square dx. 4 is a constant outside, x dx, 5 dx. X equal to, what are the limits? X equal to 1 to 2. So what is I is equal to now? This will become I is equal to 3 power rule, x to power of 2 plus 1 by 2 plus 1, 1 to 2. 4 x to power of 1 plus 1 by 1 plus 1. Here I'm asking, what is the power here? 1. 1 plus 1 by 1. Here integral of dx will be x 1 to 2. 3 x cube by 3, 1 to 2. 4 x square by 2, 1 to 2. 5 limits 1 to 2. So further, the value of I, 3 get cancels here. So this will become x cube 1 to 2 x square 1 to 5 1 2. This will become 2 cube upper limit. First you have to substitute upper limit minus 1 cube. This will become 8 minus 1, 7, 2, 2 minus 1, 1, 5, 14. This is the area under the curve. Square units, you write it. What is that 14 square? So what you should write? What is this, sir? What is the meaning? Area of yellow color region. Got the idea now? So this is what we are doing, nothing big. What is the meaning of integration? That is the major part. Like this, you can draw a curve, nothing wrong. then area under the curve is asking. So we cannot do geometry method. We have to come to integrate. There's no other way. We will go to the few more steps. Few more examples will take, because you have to just learn how to integrate a function. I is equal to, find the value of three x square minus x2 x squared plus 4 into dx. Find the value of I, or find I is asking. So there is no limits, so it will become indefinite integral. So then this will become 3 dx by x square minus this will be x square dx 4 integral dx. So what are the limits? It's an indefinite integral. We'll end up with an expression. Then this will be further x to power of minus 2 dx minus this will be x square dx 4 x to power of 0 dx, because 1 into dx we can in this way. No, here come for this one. Power rule you applied. 3 x to power of minus 2 plus 1 minus 2 plus 1 minus x to power of 2 plus 1 by 2 plus 1, 4 0 plus 1 0 plus 1, 3 minus 2 plus 1, so this will be x to power of minus 1 all divided by minus 1 minus this will be x cubed by 3. This will be x by 4 into x by 1 minus 3 by x minus x cubed by 3 plus 4x. Look at here, we ended up equation, an expression. So therefore, and after integration, you have to write that integral constant. There's a rule. What is C? C is an integral constant. Okay. Like this, we can integrate any function, quadratic functions, any functions we can integrate. So some basic rules are there we have to follow. Let's explore some other functions. Integral of x to power of minus 1 dx will become integral of dx by x. This will become log x to the base. There's the formula. So what is the meaning of this? Okay, you have written some equation. What is the meaning of this? Or we have to just blindly accept you? Whose side? Science is not about accepting things blindly. I think that there's a totally wrong, no? So what is that x to power of minus 1? What do that function? It is like a this is what, no? Yeah. So y equal to 1 by x. What is y equal to 1 by x? It's a curve, rectangular hyperbola. This is y. This is x. So now what you are suggesting is like, you assume a infinitesimal, a rectangular strip of infinitesimal width. Add up such area of, add up all like a some all that elemental areas. That area should become equal to log x to the base. Means what do you mean by that? That area from here to here, all those areas when you add up, no, that area it is just equal to log x to the base. Hope able to understand the meaning of this integral of dx by x is y log x. Here you have dA, like that you sum up the rectangular strips of infinitesimal width and increasing height from where? From x equal to 0 to x equal to infinity. You will end up with area under the curve is nothing but equal to log x to the base. You'll get a value that is equal to log x to the base. That's what the meaning here. Sir, I'll put a limits. Then what you're going to do? We'll take the same function with limits. Y of dx, where y equal to 1 by x. Limits are a to b. So what I'll do is, like, in place of y, I'll substitute 1 by x. So this will be 1 by x dx limits a to b. Then this will become log e to the base x a to b. So the limits will be log b to the base c log a to the base c. That's the meaning of this. You are adding in certain limits. Then the integral of, so let the function be y equal to e to power of x. The integral of this is y dx, or this is e to power of dx. Again, I'll end up with e to power of x only. Or so what does it mean? And we know derivative y equal to e to power of x. If I differentiate, dy by dx are equal to e to power of x. What is this, sir? You integrate that exponential, again you'll get exponential, same function. If you differentiate, again you'll get same function. So here the meaning of this is, suppose if you have I need a lot of space. We'll keep things in this way. No, let me bring the curve. So what he's saying is, like, if you have a curve, y equal to e to power of x, y equal to e to power of x is something exponential. Then at any point you draw a tangent, because that's what dy by dx is what? Slope of the tangent drawn at a point. At x equal to, and corresponding to that, so where you are going to draw dy by dx. So if you draw a tangent and you calculate this theta, what do this theta will give? Tan theta. Tan theta will be e to power of x only. No, let me write x equal to 1. Then you will end up with y equal to e. Means corresponding to x equal to 1, there you calculate, there's a curve. And what is this? Red color one? Tangent. Corresponding to x equal to 1, there you draw a tangent and calculate the slope. So what should be the value of slope? Will become equal to e. That's the meaning of this one. So therefore, the derivative of e to power of x will be e to power of x. There's a reason here. And what about, sir? The integral of e to power of x is again e to power of x. Can you give any interpretation so that we will understand rather than accepting it blindly? Yes. Here also we have the same specific reason. No, y dx. If I plot this curve, put x equal to minus infinity. Area under the curve. Put x equal to minus infinity, it should come. X equal to minus infinity. What do you mean by x equal to minus infinity? What is the value of y when x equal to minus infinity? First, we'll have that particular data. y equal to e to power of minus infinity. At x equal to infinity, so at x equal to infinity, what is the value of y? E to power of minus n will become 1 by e to power of infinity. E to power of infinity will be 0. So therefore, at x equal to minus infinity, the value of y will be 0. Then at x equal to 0, y will be e. So therefore, the curve is going to be, now will start increasing exponential. This is the value y is equal to 1 at x equal to 0. Then afterwards, it will increase exponentially. Now, what is the integral of e to power of x dx is equal to e to power of x only, means the area under this curve. From where minus infinity to, for x greater than 0. The area of all this area, again, if you calculate, it is in fact equal to e to power of x, certain value of x we have chosen. This overall area, again, how much it is equal to the x. So what is the y you're showing that upper limit? Something you're going to choose a limit, no? What is the area under the curve from in this region? Again, it will be equal to this total yellow color area is given by this particular formula. Substitute the value of x. So there's a meaning of the exponential. Integral of exponential will be exponential. Derivative of exponential will be exponential. This total area is I. Getting this one? So everything, so like mathematically, first you accept it. Then what happens? You should understand what is the significance, what is the meaning of this. Slope means always, what is the thing? Slope means, derivative means slope of a tangent drawn in y graph. What do you mean by integration? Area under the curve. I think that these are the only two primary things around which all this calculus is evolving. Okay, finally, next we'll go for some other functions. So integral of sine x dx will become minus cos x with certain limits. So again, we know sine x graph. +1 -1. So the area under the strip is this one. You add up this area, certain limits from A to B, you'll get the area under the curve. So what is the minus cos x means? You just add up all these areas. That should be equal to minus of cos x value. Similarly, integral of, now I'll try to avoid everything drawing diagram. Integral of cos x dx will be sin x. Integral constant you put it if you want to write it. Let it be plus c. Then integral of sin ax dx. So here you should see that coefficient of x must be same. When you're integrating, you have to see that coefficient of x must be same. Here it is 1, it is a. So this will become sin ax derivative of ax. So this will become, next step I'll commit. So this will become further al1 al sent inside. Derivative of sin x will be minus cos ax by a plus c. You have to see that when you're integrating, the quotient of this x must be same. So what is the value of this? Integral of cos ax dx. Again, the similar method. One by a cos ax derivative of ax. This will become plus sine of ax by a plus c. Integral of e to power of ax dx. This should become 1 by a e to power of ax. Next terms, integral of dx by 1 plus x will become log of 1 plus x. If I give some upper limit alpha, beta, limits I'll put it. So those limits you are going to take care in this way. Log of 1 plus beta minus log of 1 plus alpha. Limits are there. No limits are there, put integral constant. Integral of secant square x dx. This should be equal to tan x. One more. Integral of dx a plus bx. Quotient of x should be same. So divide and multiplied by b. Dx by a plus bx. So then this will become 1 by b. Derivative of bx a plus bx. Sir, I'll bring limits. Okay, no problem. Here also alpha beta. Limits are alpha beta. Then 1 by b. Derivative of bx. So this will become log of a plus bx. So the limits are alpha and beta. Now, what is the value of this further? 1 by b log of a plus beta x alpha x. Integral of tan x dx equal to minus of log of that integral constant, you bring it. Then integral of cosecant x cot x dx. This should be minus of cosecant. There are some formulas are there. Just I'm writing it. No need to memorize. Integral of log x to the base c dx is equal to x log e to the x minus x. Okay, these are the some various functions are there which you are supposed to remember. But what is our basic thing? Area under the curve is integration. Area under the curve is what? The value of integral. And there are two types of integrals are there: definite, indefinite. Indefinite will lead to certain expression. Definite will lead to certain value. So what you're getting? Some expression here. If you put a limits and solve, you'll get a value here. This equation here will end up a value. Here we are ending up with expression. So therefore, indefinite integral. So I'll indefinite integral leads to an expression. Definite integral leads to an value. After this, we'll go for the next application based on integration only. Finding the length of a curve. Finding the length of a curve. How to find out the length of a curve? This is a very difficult thing.